Okay, so these free response questions on AP Classroom, some of these are like next level. These things are pretty tough. This question in particular brings in a lot of different things, not only from this unit, but from also units in last semester. So we have this graph here, and be aware of what you're looking at. This is the graph of F, and it's got these letters filled in that are representing the areas under the curve. So if we read the prompt here, it says the figure above shows the graph of the continuous function f, and then the regions A, B, C, D, and E have these numbers, 5, 2, 16, 5, and 6. So I'm just going to throw those in real quick. So A, it says, is 5. And notice that A is above the x-axis, so that should be a positive area. But when you look at B, B is below the x-axis. B is equal to 2, but the area itself would be negative 2 because it's below the x-axis. C is 16, that's above the x-axis, so that can stay positive. D is 5, that's below the x-axis, so that would end up being a negative 5 area. And then E is also below the x-axis, so that'd be a negative 6. And then it says for this interval, negative 7 to 9, which is the same as the graph, the function g is defined by g of x equals negative 6 plus the integral from negative 3 to x f of t. So g is defined by an integral. By the way, this is actually called a function defined by an integral. And I've mentioned before, we're going to get into these more and more, but these are very common AP exam questions. Your performance final for this class is going to be over a question kind of similar to this. But by the time we get there, you're going to have so much practice over these, you're going to be a pro. So part A says that, is there a value of x for negative 3 to 2 such that g of x is equal to 0? Justify your answer. So we have an interval. We have an interval from negative 3 to 2. So let's say this is our A, this is our B. And we're asked to find, is there some value in between our A and our B that this is true? Well, there was a theorem that would pull this together for us, and that was the intermediate value theorem. So if you don't have the intermediate value theorem memorized, that's okay. Just go back and look at your notes. But the intermediate value theorem, in order to use this, you have to first show that your function is continuous. So in order to get full credit for this question, I believe this is scored at like 2 points. 1 point is purely just addressing the continuity. So the question here is, this is all about G. So is G continuous? Well, the big idea here that would bring this together is that if a function is differentiable, then it is continuous. And this is something that we covered like way back in Unit 1, or yeah, probably Unit 1, when we first studied continuity with derivatives. If you can show that a function is differentiable, then it must be continuous. So can we show that G is differentiable? Well, we have a function for G. We know that G is equal to this right here, negative 6 plus that integral. So let's take the derivative of that and see what happens. So I'm going to take the derivative of negative 6 plus the integral from negative 3 to x f of t dt. Well, if I take the derivative of the negative 6, that just gives me a 0. And then I'm left with trying to find the derivative of this integral. And that should look really familiar. That is your second fundamental theorem of calculus. If you take the derivative of an integral, where the upper bound is a variable, you can just say that this is equal to f with that upper bound plugged in. So this would be f of x. And this is by the second fundamental theorem of calculus. Well, in order for something to be differentiable, that means that the derivative is continuous. And if we go back up here and look, it tells us that f is continuous. Continuous function f. So we can just write a sentence here to bring it all together. Since g is the antiderivative of continuous function f, g must be continuous. And we really only care about the interval here, and we're care about this interval from a to b, -3 to 2. So it must be continuous on -3 to 2. So that's me directly addressing the continuity question. So this is actually continuous. So now that we've addressed that, that would be 1 point right there. You get a full point for doing that. Now that we've addressed that, we can actually finish the intermediate value theorem. So what we need to do is test the endpoints here. I need to see what's going on at g of a, which would be g of -3, and what's going on at g of 2, which would be your g of b. So g of -3 is going to be, and I'm just going to plug -3 into the function of g. So that's -6 plus the integral from -3 to the upper bound of -3, f of t dt. So if the upper bound and lower bound of your integral are the same, that just means you get 0 for that integral. So this answer would be -6. And then if I plug in 2, I would have -6 plus the integral from -3 to 2, f of t dt. So now I can figure out, well, what's the area under the curve of f between -3 and 2? Well, between -3 and 2, that's just 16. The area under the curve between -3 and 2 was given to us. That's c, which was 16. So that would be -6 plus 16, which would be 10. So now we can pull all this together with a sentence. We can say since g of -3 is less than 0, so g of 3 was -6, that's less than 0, and that's less than g of 2, which we already showed was 10. That means that g of x equals 0 for some x on -3 to 2. And then you have to state the theorem that brings all this together, and so that is by the intermediate value theorem. And that right there is really your answer. So you get another point for this over here. If you did all the work and didn't state the intermediate value theorem, they might actually not give you the point at all for that. So that's part A. Part B says to find the absolute minimum value of g and the absolute maximum value of g on the interval. Well, if you're looking for absolute extrema and you're given an interval, the extreme value theorem will do this for you. Let's do this in white. Extreme value theorem. And so you might remember the extreme value theorem had a bit of a process. You first want to find your critical points, and then you want to create a table. Creating a table which shows all of the y values of your critical points and then also the y values of your endpoints. So I'm looking for absolute min and max of g itself. So if I'm going to find the critical points, I need to start off by finding the derivative of g. And we already did this work, but I'm just going to throw it out here again. The derivative of g would be -6 plus the integral from -3 to x of f of t dt. That would be f of x. So g prime of x is actually just equal to f of x. So if I want to find my critical points, I have to set g prime equal to 0, which means that f of x is equal to 0. And f of x equals 0, I can find those answers on the graph. F of x is equal to 0 whenever this thing hits the x-axis, because we're looking at the graph of f, right? So this thing is equal to 0 whenever I have x-intercepts. So those values would be -7, -5, -3, 2. -7, -5, -3, +2. Let's go back. I think it was +2. And also, yeah, +2, and then it was 6 and 9. So we got a bunch of values here. So these are all of our critical points. You might also make sure that these are all within the interval that we're asked to find this for. But the interval does go between -7 and 9. And all of our critical points that we found are between -7 and 9, including the endpoints. We also have to consider is g prime does not exist. And that would just be the empty set because g prime is defined as f is continuous. If f is continuous, that means it exists everywhere. So empty set for does not exist. So the second part of this is building our table. So we want to list x values in our first column, and we have to plug all these things back into g. You always want to plug it back into your original function. We're finding min and max of g, so we plug it back into the original g. And the x values, let's just list them all out here. So it's -7, -5, -3, 2, 6, 9. Okay, so we're gonna go one by one and figure these things out. So let's start off with the -7. G of -7. So g is defined as being -6 plus the integral from -3 up into your boundary here, which is -7, f of t dt. So now I can use the table to figure out what is this integral. I need to figure out what's the integral between -3 and -7. Notice that my boundaries are going backwards here. Let me erase some stuff. Let's get rid of that, that, and that. So -3 to -7, I'm working backwards. I'm starting off at -3, and I'm integrating left. Well, we can actually fix this by swapping the boundaries. So I could say, and when you swap the boundaries, you have to change the sign of what's in front. So if I swap the boundaries, I need to put a negative sign, and this would go now from -7 to -3, f of t dt. So now I can read the graph. I should have done that before I looked at the graph. Now I can read the graph, -7 to -3. I just have to add up these areas. It'd be 5 and a -2. 5 minus 2 is 3. So then I get -6 minus 3, which would be -9. So that first answer is -9. Do the same thing for -5. G of -5 would be -6 plus the integral. So this would go from -3 to -5, f of t dt. I need to swap the order of integration, so I'm going to do minus integral -5, -3, f of t dt. Remember, you always want to try to read these graphs from left to right, so that's why you have to swap the order of integration. So the integral between the area under the curve between -5 and -3 would just be that -2. That's that b value. So this would be -6 minus a -2, which means I have to add 2. So that's negative 4. Excuse me. So that's negative 4. Negative 3. If I plugged in negative 3, my top and bottom boundaries would be the same. Also, we figured out g of negative 3 somewhere else, so I'm just going to say that's 0. The positive 2, we figured that out earlier. Didn't we? Maybe we didn't. G of 2. Pretty sure we did, but maybe not. So g of 2 would be negative 6 plus the integral from negative 3 to 2 f of t dt. So I believe that was 16. So negative 6 plus 16 is 10. And then we have 6, g of 6, that's about 6. G of 6 is negative 6 plus the integral from negative 3 to 6, f of t dt. So then I have to add up all the areas between negative 3 and 6. So that means I'm adding up 16 and then minus 5. 16 minus 5 is 11. So negative 6 plus 11 is 5. And then finally the 9. G of 9 is equal to negative 6 plus the integral from negative 3 to 9 f of t dt. So that's that 5 that I just got, plus the last piece, which was the negative 6. So that's negative 1. So we're asked to find the absolute max and min. So we just have to look at our table. The absolute max is the biggest value I see here in the y column is 10. So absolute max is 10. And the absolute minimum is the smallest y value, which is the negative 9. And there's your answer to part B. Excuse me. Sorry, I'm sure I sound disgusting right now. Part C, we need to find that integral. This first part is easy. This is just a straight up indefinite integral. The antiderivative of 2x would be add 1 to the exponent, so it's x squared, divide by the new exponent, and then plus 16x, add your c, and then simplify it a bit, which you don't actually have to simplify these, but whatever. So there's the answer to part I, part 1. Second part is a little bit more tricky. Remember, this is part of the U-Substitution homework, so that kind of gives you a hint of how to solve this. If you want to find the integral and you have a composite function, use U-Substitution. And we do have a composite function. Our outer is f, and our inner is this right here. So let u equal that inner function. That would be 2x plus 16. And then take the derivative of both sides. And then make your substitution. So this thing right here would equal the integral. So instead of the 2x plus 16, I'm going to write this as f of u. And then the dx part would be 1/2 du. You just divide both sides by 2. So 1/2 du equals dx. I need to figure out the boundaries. So we've got boundaries from -7 to -5. So I have to plug in my -7 into u. That'd be 2 times -7 plus 16. -14 plus 16 is 2. So -7 was the lower bound. So 2 is my new lower bound. And the -5 was the upper bound. U of -5. I'm trying to hurry because I think my iPad is about to run out of memory. Negative 10 plus 16 is equal to 6. These videos take up a lot of space. Okay, so upper boundary is 6. So then I need to figure out, I can pull the 1/2 out front. So I need to figure out what's the integral from 2 to 6 of f of u du. Well, the u doesn't really matter here. That's supposed to be a u inside there. Let me try to fix that because that's ugly. So the u doesn't really matter. Remember, u is just an arbitrary variable. This is just telling me to go to the graph and figure out what's the area under the curve between 2 and 6. So if I do that, between 2 and 6, notice that's just this piece here. And the area under the curve is -5. So then this would be 1/2 times -5. And then if you simplify that, it's -5/2. And that is your final answer.